Okay, good morning to you. Okay, we want to look at quantitative method. So we'll be solving the problem on quantitative method, and that's under decision analysis. Now, from the question, we are told that a businessman wants to decide purchasing one of the three types of financial securities. Three alternative securities are available to him, and we have A, B, and C. The state of nature are expansionary, normal, and contractionary monetary policy condition. The profits associated with each security are shown in the following payoff metrics. Now we are given three alternatives here. These are the three alternatives what this particular businessman want to embark on. Alternative A, B, and what C, which are the securities you want to embark on. Now we have the state of nature of this security, expansionary, normal, and contractionary, and look at the expected payoff, the payoff for each of them. Now we are given the probability for each of the states of nature: 0.35, 0.4, 0.25. Now the addition of this probability should be equal to 1. Now look at what we are asked to do. Look at what the question wants us to do. Question 1 said, construct opportunity loss table. That we should construct an opportunity loss table. Question 2 said, what is the maximum expected monetary value? Question 3, what is the expected value with perfect information? Question 4, calculate the expected value of perfect information. Now look at the fourth question we asked to what? So now we are going to start with the first one, which is said we should construct an opportunity loss table. Now opportunity loss table is a table that summarizes all the losses you will encounter, as a result of not embarking on the best payoff in each state of nature. Not embarking on the best what? Payoff from each state of what? Nature represents your opportunity loss. Now, solution to this now, based on question I. Now we want to show our opportunity loss table. Opportunity loss table. Please pay attention to this. Now we have three security we want to embark on: security A, B, and what? And C. Now on the first state of nature, which is expansionary, like I said, opportunity loss table is a table that summarizes all the losses from each state of what? Nature. The losses based on the businessman not embarking on the best state of what? Nature. Now please look at the first one, expansionary. Now what is the best state of nature here? The best means the highest payoff is the best state, is the what? Is the best payoff there in this state of, in this particular state of what? So the best payoff is what? 8,000 naira. Now the opportunity loss for this expansionary will be if you choose not to embark on the best what? Payoff. What will be your what? Losses. Now for the first one, which is expansionary, the best payoff here is what? Which is for what? Security A. So meaning we use the best payoff and reduce each of the what? Payoff from. Now if this is the best payoff and this particular businessman decide to embark on this what? On this decision, is he going to lose anything? So it becomes what? 8,000 minus what? Meaning he's losing what? Nothing. But if this man choose to embark on what? On B, which is not the best what? The best payoff. How much will this man be losing? To that be minus 1.6. If this man choose to embark on what? Based on this state of what? He will be losing what last? Minus 1.4. Now this will give us what? This will give us what? 4,400. 8,000 minus 14. 6,600. Are you there? Now this is based on what? Now let's go to what? Let's go to normal. What's the best payoff here for normal? So if this man choose not to embark on what? On decision what? Alternative A. If he decide to embark on A, it means he's not losing anything, Abi. 4,000 minus what? Which is what? Now if he choose to embark on what? B. On this state of what? Which B is not the best one, Abi. He'll be losing what? Minus 2 for which is what? If you choose to embark on what? Which is not the best payoff, Abi. In this state of what? You'll be losing what? How much? Now this is based on what? On normal, Abi. Now let's now see what? Let's see the last state of what? Nature, which is what? Contractionary. What's the best payoff here? 1/8, Abi. Which is what decision? B, Abi. So if this man choose to embark on what? On A, he'll be losing what? That is 1/8, Abi. Minus which is what? If he choose to embark on B, which is the best, Abi, he will not be losing anything, Abi. 1/8 minus what? Which is what? If this man choose to embark on what? Which is not the best payoff, Abi, he'll be losing what? Now that will give us what? Now with this class, the answer for each of them is what I will now use to now prepare my opportunity loss what? So I will now summarize it in this way. Opportunity loss table. Opportunity loss what? Table. Now decision, we have them A, B, and what? C. Then we have state of nature B, which is what? Expansionary, normal, and what? Contractionary. Now from what we have done, from our answer, for A, we have what? The first one is what? 0 for expansionary, B. 0 for what? And 800 for what? For decision what? For B, we have what? 6,400, 1,600, and what? And 0. Now for C, we have what? 6,600, 2,600, and what? And for now probability, we have what? 0. What? 0.35 ahead, 0.4, and what? 0.25. And class, this is your opportunity loss what? To answer question what? I. Now question I said, what is the maximum expected value based on this question? Now your expected value is calculated as the summation of the probability of each of the decision, the summation of the probability of each of the payoff in each what? Decision. So to get the expected value for decision for A, expected value for security what? A. Now what we are going to do is to use the probability here for expansionary to multiply the payoff of A. Use this to multiply the payoff of what? Of A on normal, and this for what? Contractional. Now we have 8,000 times what's probability here? Plus, because it's summation. Are you there? Plus, for the second state of what? What is the probability here? And what's the payoff? Still on what? Security what? A. So that will be 4,000 times what? 0.4 plus the third state of what? Nature based on decision what? What is probability here? And what is the payoff? So we have 1,000 times what? 0.25. So please break it down for me. Here is what? Plus what? 16 plus what? 250. Now final answer is what? 4,650 Abi. Now remember is 1,000 Abi. So that will give us what? Final answer will now be what? 4,650 what? Million, because I'm not writing in final answer because we have it in thousand already. I get to me. So just like this amount times what? 1,000 to get your full what? Value. So that's what decision what? Now for security B. Security B now, what is the probability here for the first state of nature and what's the payoff there? So that's 1/6 times what? Plus 2/4 times what? 0.4 plus 1 what? 1/8 times what? So we have what here? 560. 9 what? Plus 4 what? 450 abi? Now give us what? 1,970 abi? Now because it's 1,000 abi, I'll now do times what? 1,000 to get the final answer as what? 1,970,000 what? That's for B abi. Now for C, for security what? What's the probability here? So that's 1,400 times what? 0.35 times 1/4 times what? Plus 1/4 times what? So we have what? 1/4 times 0.35, 490 plus 560 plus 350 abi. Now give us what? 1,000. Now take it to what? To million times what? That will now give us what? 1,400,000 what? Now the expected payoff, the expected value for A is what? 4,650,000 abi. Expected value for B is what? Expected value for C is what? 1.4 million abi. Now the question said, what is the maximum expected monetary what? So the maximum expected monetary what will not be used as a basis for our what? Decision. Now, which of these expected value give us the maximum here? So therefore, based on question this, the maximum expected monetary what? Monetary value is how much class? Formula what? 650 what class? And the decision there is to embark on what? Security what? A. The decision is to embark on security what? Because it has the highest or maximum expected monetary what? Value. And this is what question what? I want us to what? To solve. Now the third one we want to solve is what is the expected value with perfect information? Remember we are done with the maximum expected monetary value. Now the next question said what is the expected value with perfect information? Now take note that the expected value with perfect information, using perfect information, the decision maker will use the highest payoff of each state of nature to get the expected value with perfect information. The decision maker is going to select the highest payoff, the highest what? In each state of what? With their what? Probability, and add up them together. That's your final what? Answer. So expected value with perfect information will now be equals to, now in this your first state of what? Nature, what is the highest payoff here? So that we'll pick that one. 8,000. That's the perfect information. 8,000 times each what? 0.3 what? Plus what is the highest payoff in this state of nature here? So that will be 4,000 times what? 0.4 plus what is the highest payoff here? That's 1,800 times. So now we'll be having what now? 2,800 1/6 plus what? 450, and now that will give us what? Before multiplying by 1,000, that will give us what? 4,008 what? 850 abi. Now times what? To put it in what? In million. For that will give us how much now? 4,850 what? Thousand naira. Now that is the answer to what last? Question I. Then finally question I. Question I we said what? Calculate the expected value of perfect information. Expected value of perfect information is the difference between expected value with perfect information and expected value without perfect information. Are you there? Expected value of perfect what is the difference between expected value with perfect what and expected value without. Now expected value without perfect what is our maximum expected monetary what value calculated, while this is our what expected value with perfect what. So class, therefore expected value of perfect what information will not be equal to EVW1 PI minus what expected, or let's use maximum or expected value. Expected what class? Value. That's the maximum expected what class? Value. Are you the class? The maximum expected. So this will be equals to what is the expected value with perfect information? 851 minus 4,006,000 what? Now that will give us final answer. 200 what? As our final what? Answer for this. So that's just what you are asked to what? To solve. And this is solution to the problem. Are you the class?